Hello all. In the previous series, we have seen difference between machine learning and deep learning. So what is perceptron? Why do we need deep learning? So what are the components that are required for designing a neuron, right? So in this lecture series, so we are going to see SLP and MLP. So that nothing but a different types of neurons. Okay, so we are going to see SLP and MLP. Those are nothing but different types of neurons. Yeah. First one, what is single layer perceptron? Okay, SLP. So first, while designing a neuron, so first they have designed a SLP, single layer perceptron. So if you look into the diagram, see, so these are the inputs. So this is how it looks. Okay, so these are the inputs. Okay, these are the weights, bias, and activation function and output. Okay, so if you look into here, so we need inputs, okay, bias and activation function to design or to get an output in SLP. Okay, so this is a diagrammatic representation. Okay, so you can draw like this. So you can create neurons x1, x2, x3 and so on, xn, w1, w2, w3, okay, like this, okay, wn, so and so on. Okay, so you can connect like this, so that information will be passed on. So we will be summing up here. So we will be summing up here. Okay, summation happens. So during summation, what will happen? Wi, xi. So wi means weights. Okay, xi means input or feature. Okay, then here what will be giving? Bias. So why we need bias? Why we need bias? Okay, to make the neuron to give information to the another cells. Okay, to give information to the more number of neurons, we need a bias. Okay, to amplify it. Okay, so then after adding bias, then we give it to activation function. Activation function. So there are different types of activation functions that will be used based upon the scenario or data set. Okay, so then we'll get an output. Okay, so if you observe here, so how the SLP process is working? So it is working under two steps, if you ask me. Okay, so in the first step, okay, the inputs and weights are getting added. Okay, so here, so summation of xi, wi is taking place. So this is nothing but a x1 w1 plus x2 w2 plus x3 w3, so and so on, xn wn. So if n neurons are there, the summation will look like this. Okay, representation looks like this. Okay, so all those summation will take place in first step. Okay, step 1. So in step 2, what happens? So we will be adding the activation function. Okay, f of x summation of xi wi. Okay, so f of x is the nothing but a activation function. So there are different types of activation function that gets added to this summation. Okay, this is step 2. Okay, then after this we'll get a output. Okay, this activation function helps to whether neuron to fire or not, whether the information should be passed on to next neuron or not. Okay, yeah, you can see it here. Okay, what is the first step? Okay, in the first step, what are the things? Summation of the inputs and weights are getting summed up. Okay, so in the next step, what we are doing? So we are getting like this. So finally, what we are able to get? Summation of xi wi or wi xi. We can write anything. Okay, so we can add bias also. It's an option. Okay, so it's an option. We can add bias also. So to this, we are adding activation function f of x. Our f of x is nothing but this one. Okay, so finally the last step will look like this, the output. Okay, with the help of two steps, we are able to generate the output of a SLP. Okay, so in SLP we have two steps. Okay, yeah, what is the drawback? So are there any drawbacks? Okay, means I can say yes, there are a few drawbacks about this SLP, single layer perceptron. Okay, so single layer perceptrons will not support XOR gate. Okay, so if you take logic gates, AND gate, OR gate, NOR gate, okay, so SLP will not support XOR gates. Okay, exclusively OR function is not supported in SLP. Okay, so there is another disadvantage or drawback of SLP, that is it did not have enough processing power. Okay, so this simple neuron is not capable of handling the big data. Okay, so big huge data is not able to handled by this single layer perceptron, okay, network. Okay, so that's why we need to remodify this. Okay, we need to remodify this neuron or single layer perceptron network. Okay, so if you have only inputs and outputs, then it is called as SLP, two layers. Okay, in between we have bias and activation functions also, but on the whole, but we will say there are two layers only, input layer and output layer. Okay, so this is not enough, right? So it is not able to perform XOR function, and it is not able to handle large data. It is not able to process huge data. Okay, and one more thing also, it cannot separate non-linear data. Non-linear data is not supported by SLP. Okay, this is third one. Okay, so what is non-linear data and what is linear data? Say suppose, so I have two different variation points. Okay, so if we use one separator, we can see. Okay, so one points is getting separated, the other points are getting separated. Okay, so if the problem is like this, if the data is separable, then we can use single layer perceptron. But if we have data like this, okay, so if we have data like this, okay, if you have data like this, so we cannot draw a line, perfect line that differentiates total similar points and the other similar points. Okay, we cannot differentiate between two or more components, okay, with the help of the line. So this is non-linear data. Non-linear data which is not separable. Okay, this is linear data. Okay, if you draw a line, we can separate the two different points. Okay, this is linear data. Okay, so non-linear data. Okay, so non-linear data is not supported by SLP. Okay, not supported by single layer perceptron. That's why we need to remodify. Okay, these are the three main reasons that are the drawbacks of single layer perceptron. Okay, so what we need to do? We need to remodify, right? So how we can remodify this SLP? By adding one more layer. Okay, so that one more layer is nothing but a hidden layers. Okay, so we need to add now hidden layers. Okay, yeah, this is the extra layer that is coming. Okay, so that's why we call the name as multi-layer perceptron. So we are remodifying the single layer perceptron into multi-layer perceptron. Okay, so in multi-layer perceptron we have three layers. So input layer, hidden layer and output layer. Okay, three layers. Okay, so input layer and output layer will be similar to the SLP, but hidden layers. So what are these hidden layers? Okay, so generally we'll take 2 or 3 hidden layers. 2 or 3 hidden layers. Okay, generally. Okay, yeah, this looks like this. Okay, so I can draw similar to this also. I can draw MLP as like this. Okay, so I'll redraw SLP and MLP, how it looks. So SLP will look like this. Okay, we have inputs x1, x2, x3, w1, w2 and so on, wn. Okay, okay, so here summation will takes place. Okay, so what is the summation? Sigma xi wi. Okay, here bias will be also getting added. Okay, so plus bias. So in the step 1 this happens, right? Okay, so in the next step what will be giving? We'll be giving activation function. So that activation function will be like anything. Okay, so it will be like this also, ReLU. Okay, okay, so it will be any activation function. Okay, activation function, then we'll be generating an output. Okay, so overall the output will be like this, sigma xi wi plus b. Okay, so this is the two-step process that we generally draw to indicate a SLP. But how does MLP looks? So MLP looks like this. So first we'll have, okay, so we'll have like this 4. So for a beginner, how to draw a MLP diagram? Okay, so how does we can draw? We can draw 4 3 2 1. What is this 4 3 2 1? I can say it looks like neat diagram. Okay, neat representation of multi-layer perceptron. Okay, so these are inputs. This is hidden layer 1. Hidden layer 1. This is hidden layer 2. And this is output. Okay, so how do we this is x1, x2, x3, x4, okay, so on, okay, so on xn. Okay, let it be like this. Okay, so here h1, h2, h3. Okay, so actual notations will be not like this. So we'll be discussing how to give notations to these neurons in further sessions. Okay, so I'll be explaining there. Okay, so this is also hidden layer 2. Okay, so how do we draw, how do we pass information? So from one cell it need to pass on to remaining cells, so we can connect like this. Okay, so from these cells also, see, we need to get the point, so then only it looks somewhat better. Okay, so we can draw like this. Okay, so we can draw like this. So from one neuron we need to pass the information to the every neuron of the other layer. Okay, similarly from here this neuron, the information need to be passed to all the neurons. Okay, so from this neuron the information passed to all the neurons. Okay, this is hidden layer. Okay, okay, we'll get an output. Okay, yeah, so this is how we represent a multi-layer perceptron. So what we are having here, so here also we are having we'll add activation functions for hidden layers as well as inputs and outputs also. Okay, to fire the neuron. Okay, so here weights will be W1, W2, W3, W4, okay, W5, W6, W7, W8, W9, so on, Wn. Okay, so weights can be represented like this. Okay, so here also weights will be there, W1, W2. So actually we will see entire representation in the further sessions. So how exactly we will represent the weights, how exactly we represent the neuron, so how do we calculate, how do we update the weights of the neurons and all, we'll talk in the further sessions. So as of now you see the connection. So input layers are getting connected to the hidden layers, and this hidden layer 1 is getting connected to the hidden layer 2, followed by the output. So there are 3 layers. Okay, layer 2, layer 3. Okay, this is MLP representation, diagrammatic representation. This is SLP representation. Okay, yeah, so we'll talk about the difference between this SLP and MLP. Okay, yeah, architecture wise, if we talk about the architecture wise, what difference we have noticed? We have for SLP we have only inputs and outputs. Okay, 2 layers. Okay, so 1 layer of input and output. Okay, so multiple layers. Okay, so you can here say 1 layer, not 2 layers you can say. Okay, so you can say here 2 layers instead of 1 layer, nothing but a input layer and output layer. So here you see multiple layers. Why multiple layers? Input, output, and more number of hidden layers. Okay, more number of hidden layers. Okay, yeah, so for this inputs, hidden layers, outputs, we pass an activation function, right? So generally for hidden layers we take ReLU. So for remaining inputs and outputs we take another activation function generally. Okay, yeah, next, so inputs directly connected to the outputs, so connection. So here includes connection between inputs, hidden layer and outputs. Okay, this is the architecture difference between SLP and MLP. Next difference, functionality. Okay, so how does they function? Okay, so they are capable of solving linearly separable problems. Okay, so whereas MLP can solve both linearly separable data and non-linearly separable data. Okay, linearly separable data and non-linearly separable data. Okay, okay, non-linear separable data. Okay, MLP supports both, okay, but SLP supports only linearly separable data, okay. Activation functions, it often uses a step function or for binary classification, okay. Generally in SLP we use mostly step function, okay, for binary classification. But whereas in MLP, what activation functions we can use ReLU, sigmoid, tanh, okay, to handle non-linearity, okay. So on the whole, we can say we can use more number of activation functions on MLP. We can use mostly step function or unit function on SLP, okay. Next, feature transfer cannot transform input features into a complex representation, okay. It will not transform into complex representation, but complex feature representation is possible in MLP. So this is the overall functionality what they can do, actually really do, SLP and MLP. Next, training. So okay, it uses what training, what algorithm uses perceptron learning rule, okay. So what is perceptron learning algorithm, we will see in the next session, okay. So then MLP uses back propagation, okay. Here no back propagation is involved. In MLP there is involvement of back propagation, chain rule, memotization, and all are there, okay. Back propagation, chain rule, memotization concepts will come here, okay. In MLP, here only the perceptron learning algorithm is used, okay. Only one algorithm is here, back propagation algorithm is used, okay. How does the complexity look? Means it is low due to simple architecture. It is very simple, right? No hidden layers, okay. It is higher, okay. Yeah. Next, applications. So where it can be applied, where we can apply single layer perceptron, where we can apply multi-layer perceptron. So single layer perceptron can be generally applied to AND or, okay, XOR, if only if non-linearly separable, okay. For designing, we can remove this XOR. So it has, if it is a linearly separable only, then that XOR gate will be considerable, okay. So otherwise we don't consider XOR gate also for designing SLP, okay. So for MLP we can use complex tasks like image recognition, speech processing, and NLP concepts understandable, okay. So in that case we can use multi-layer perceptron, okay, architecture, okay. So this is the brief summary of SLP and MLP. SLP is the basic neural model, and it has a limited capability, okay. It has 2 layers, okay. So MLP can handle more advanced model, okay. It is a more advanced model. It overcomes the limitations of SLP. Yeah. So see, when designing MLPs, okay, MLPs, multi-layer perceptrons. So there are many layers coming, right? Multiple layers are coming, okay. That nothing but a hidden layers, more hidden layers are there. So in that case, what happens, the memory size. So how to handle that memory limitations in while designing MLP means there are few techniques, okay. So ironing and MLP memorization. So while designing multi-layer perceptron, so we can overcome the memorization problem with these techniques, okay. So we can start with a small network and gradually increase it. So directly designing a complex architecture is a drawback. So we can simply gradually increase from small to big, okay. So while designing complex architectures, MLP architectures, okay. So we can use L2 regularizations as default, okay. So we have many we have 2 types of regularization techniques, like L1 and L2, okay. So one is squares, okay. The other one is absolute values. So here absolute values can be considered, okay, okay. That reduces the memory size, okay. Squares means the product size will also be bigger in L1 regularization. So that's why we can use L2 regularization generally, okay. So we can use early stopping, okay. So in early stopping, what happens, we can consider main neurons instead of all the input neurons. We can consider main features, like important features like eyes, ears, nose, to classify an image instead of all the features like tongue, teeth, okay, so ears, neck. So all those features, instead of all the features, we can consider only main features, okay. So we can avoid this considering of main features in early stopping, because in early stopping we can omit the unimportant features, okay. So in that way we can reduce the memory size. Okay. Next we can experiment with the data augmentation. Okay, so we can there are different augmentation techniques. Okay, so one is changing the angle. So what is augmentation generally? So same image, if you want to generate similar type of image, then that is called as augmentation. So how you can generate similar images? So I have an you take my image. Okay, so to my image you decrease the brightening size and increase the brightening size, and you can generate, depending upon the brightness, you can generate different types of images of mine. Okay, so you can change the angle also. So my angle like this. Okay, like this, or you can change the image angle also, and you can generate. Okay, you can use the brightness. Okay, so you can use changing of angles. Okay, so in that way you can modify the data. Okay, so modify the data and retake the inputs. Okay, nothing but an augmentation technique you can apply to reduce the memory size. Okay. Okay, so next, monitoring the curves, training and validation curves. Okay, in this way also we can reduce the memory size while designing an multi-layer perceptron. Yeah, so that's it for this session. We have understood about SLP and MLP, right? So in the further sessions we'll discuss about some more concepts of deep learning. Okay, thank you all. Thank you for giving this opportunity.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.